Hello and welcome to our mathematics lesson. We continue to build up on the topic quadratic expressions and algebraic fractions. During our last lesson, we were able to cover two aspects. One was an expansion of binomial products, and two was perfect squares and difference of two squares, which we said when summarized they can give us three rules which we can be able to easily expand quadratic or binomial products, and we said that these three will be referred to as the three quadratic identities. The first one, if you have a plus b squared, which is a perfect square, this will end up giving you a squared plus 2ab plus b squared. Number two, if we have a minus b squared, then this will give us a squared. The sign changes to be minus 2ab plus b squared. Then lastly, on the difference of two squares, is that if you have a plus b multiplied by a minus b, the order does not matter. You can begin with a minus b multiplied with a plus b. The result will be a difference of two squares, that is a squared minus b squared. We are also able to look at a number of examples. During this lesson, we want to look at another subtopic, that is factorizing algebraic expressions. Now, algebraic expressions makes good use of the pronumerals or the alphabetical letters in the expressions, where we are going to have two terms in a particular expression as such. Now, the process of factorization is the opposite of expansion. You remember that in our last lesson, we discussed on how expansion is done on binomial products. So the reverse process can be asked. Like, for example, if you are given (40) subtract 16b, this is an expanded expression which we can factorize by picking out the factors that are common for the both terms, that is 40 and 16, as we are going to see. Now, factorization is very important because it is normally a key in simplification of almost all mathematical problems. Now, during factorization, there are steps that are supposed to be followed. First, we need to say that when factorizing, expressions, with common factors, take out the highest common factor, which sometimes we shorten it as HCF. And this HCF could be of three natures. So there are three possibilities for the HCF. One, it can be a number. Just any number, like for example, when you have 2x plus 10. So you'll discover that the highest factor that is common between these two terms is a number, and this number is what? 2. 2 is common in the first term, it's common in the second term, and therefore we need to take it out. So when you take it out, we'll say that you have factored using the HCF. So the HCF of this expression is 2, and that will be 2 into 2x divided by 2 is x, 10 divided by 2 is 5. Number 2, it can be a variable. Variable in the sense that it can be a pronumeral beginning from A to Z of the alphabetical letters. For example, if we have x squared plus 5x, this is a binomial expression. Now you can be able to appreciate that the value that is common between x squared and 5x is x, and therefore you can be able to factor out x. That is the highest common factor. So that will be x into x goes into x squared x times, x goes into 5x 5 times. You will have factorized. So in this case, that particular highest common factor can be a variable. Number 3, it can be a combination of the two, a number and a variable. And a variable. Example given, if we have 2x squared plus 10x, you'll be able to appreciate that for the whole numbers 2 and 10, there is a common factor which is 2, and it is the highest common factor. Then again, x is another factor. So we shall take 2 multiplied by x. So it's a product. The highest common factor has become a product of a number and a variable into 2x goes into 2x squared x times plus 2x goes into 10x 5 times. So you can now be able to clearly see that it's a number and a variable. So those are the 3 possible scenarios for the highest common factor which we can be able to interact and meet with. Another important point is that a factorized expression can be checked by using expansion. So after you are through with factorizing, you can expand and see if you'll still be able to get back the original expression. Example given, if we had 2x into x plus 5 at this stage, if you expand this, can you be able to go back to what you originally had? So let's see. So this will be 2x multiplied by x, which will be 2x squared, plus 2x multiplied by 5, which will be 10x. So indeed it is true that when you reverse, you still get back the original expression. So this is what to do, or what should be done whenever you are factorizing algebraic expressions. The most important thing is for you to know how you can be able to spot the highest common factor. And we are saying that the highest common factor can either be a number, 2, a variable, that is a pronumeral, and 3, it can be a combination of the two or a product of the two, that is the number and a pronumeral, as we're able to see. Then lastly, always check that if you expand back your factorized expression, you will still get exactly the expanded form. We now want to consider a number of examples on how we can be able to factorize algebraic expressions. Example 1. Determine the HCF. The HCF, by now you know what HCF means, highest common factor of the following. Number 1, we have 6a and 18ab. So we need to identify or check out what is the highest common factor between the two. Then number B, we have got 3x squared and 6xy. So this, it's very easy to identify the common factor, especially when we have numbers and the pronumerals. So in the first case, we have got 6a and 18ab. So you can be able to see that on the numbers we have 6 and 18. They'll be able to give us one of the highest common factor. So the term that is highest, that is common between 6 and 18 is 6 itself. So we have 6 multiplied by, we have a, we have ab. So again, a is common, so that will be 6 multiplied by a, which will be 6a. So in this case, we can be able to say that 6a is the highest common factor. Number 2, we have 3x squared and 6xy. In the first instance, we consider these whole numbers ranging from 1 to infinity. We have 3, we have 6. We can be able to note that 3 is common in the two expressions, and that is why we are going to pick 3. There is x, there is also x. That means we can be able to pick an x as being the highest common factor between the two expressions. That means the highest common factor will be 3 times x, which is going to be 3x. And sometimes, or in the coming examples, we shall now be required to use this highest common factor to be able to factorize expressions. Like in this case, if you are given 6a plus 18ab, if you wanted to factorize it, you need to get the highest common factor first. That will be 6a into 6a goes into 6a once, 6a goes into 18ab, first 6 goes into 18 3 times, then 6a goes into a goes into ab b times. So this will be 6a into 1 plus 3b. The same could have been used also here, where you are told factorize 3x squared, subtract 6xy. So you have been able to identify that the highest common factor is 3x. So we factor out 3x. 3x goes into 3x squared x times. 3x goes into 6x squared twice y. Example 2, factorize the following. Number 1, we have 40 minus 16b. Part B, we have negative 8x squared minus 12x. So to be able to solve the first part, we have 40 minus 16b. We need to identify the highest common factor between 40 and 16. 2 is a factor, 4 is a factor, 8 is a factor. But when you go to 16, 16 cannot be a factor because you can never divide 40 by 16. So that tells us that the exact or the highest common factor is going to be 8. 8 will be common to 40. It will also be divisible by 16. And it is the only one. So that means our highest common factor is going to be a number. So we are saying that the highest common factor is going to be 8 into 8 goes into 40 5 times, subtract 8 goes into 16, b twice b. That is the most simplified expression ever. You can never proceed more than this step. And if you wanted to test that actually this is the true results, you can always expand and see if it will give you 40 minus 16b. 8 by 5 will give you 40 minus 8 by 2b, it will give us 16b. So that means we are on the right track. Number b, we have negative 8 x squared minus 12x. So for us, there are several numbers here that are common, beginning of course with 4. 4 is common on the 2, 6 is not common. That tells us that we're supposed to end at 4. And because we have negative and negative, we can be able to say that negative 4 is going to be our highest common factor. So we pick to take out, and you also recall that we have got x squared and x. This will tell us that also x is another factor, and therefore we should multiply that by x into. Now negative 4x goes into negative 8x squared how many times? First, negative 4 goes into negative 8 twice, then we remain with 1x, so that will be 2x. Plus, because we now have minus outside, so this will be 4x, negative 4x goes into negative 12x thrice, and that will be positive 3. So this will be negative 4x into 2x plus 3. If you want to check that your information is true, then again you expand. Negative 4x times 2x, it will give you negative 8x squared. Negative 4x multiplied by 3, it will give you minus 12x. So you'll be able to appreciate that that is true. Example 3. We now want to see when we have a bimodal factor. Factorize the following. Number 1, we have 3 into x plus y plus x into x plus y. We simply need to factorize. Now look at this. Let me have b first. Our b says 7 minus 2x minus x into 7 minus 2x. Now in the first question, we are having 3 into x plus y plus x into x plus y. In factorizing, we said we look for the highest common factor between the two or between the given number of expressions. Look at this. We have x plus y, x plus y. Assuming that x, we let x plus y be a. That means we'll be having 3a plus xa. And you can be able to clearly see that a is common, hence it can be factored out. Hence we are going to have a into 3 plus x, or 3 plus x into a. Then when you finally replace the value of a, because our a is x plus y, then you'll get 3 plus x into x plus y. So still, that is how it can be approached. Alternatively, we have already discovered that x plus y is a common factor. So what do? So we begin by writing it down, x plus y into x plus y goes into 3x plus y 3 times. This and this will cancel. Plus x plus y goes into x plus y. This one will cancel, remain with x, which is more or less than what we already had. Number B, the same can take place. This is like the coefficient of 7 minus 2x is 1. And if we let 7 minus 2x be something like t, then that means we'll be having t subtract x t. Now for us to be able to factorize this, then we must factor out t, because t will be common, and this will give us 1 minus x. Replacing the value of t, our t from here is 7 minus 2x, so we'll have 7 minus 2x into 1 minus x, and we will have factorized. Alternatively, we can be able to spot that this and this are like or common between the two expressions. Therefore, we factor it out, 2x into 7 minus 2x goes into 7 minus 2x once. Subtract 7 minus 2x goes into x into 7 minus 2x. This and this will go, leaving us with x, which is still the same as what we have when you let the whole of it go to t. Example 4. Write down the perimeter. Write down the perimeter of these shapes in factorized form. The first one, we have a rectangle which measures 2x by 4. The other one, we have an isosceles triangle whose equal side is x and the base is 6. So we need to find the perimeter of these two shapes or figures. Now for part number 1, we understand that the perimeter of a rectangle is normally given by twice the sum of length and the width. So this will give us 2 into the length, which is 2x, plus the width, which is 4. So we can expand. The question requires us to leave our answer in factorized form, but you can still be able to see that on this part it is not fully factorized. We have 2x plus 4. So let us factorize that part. This will give us the common term here is 2. 2 goes into 2x, x times, plus 2 goes into 4 twice. So that means outside we're going to have 2 times 2, which will give us 4 into x plus 2 as a factorized form. Part B, we have an isosceles triangle. This side is equal to this side, hence it's going to be equal to x units. Perimeter is normally given by side plus side plus side, which is simply 3s. That means we are going to have, because all the sides are not equal, we are not going to have 3s. Hence the perimeter is going to be twice x plus 6, which is an expanded form. So the question requires us to write it in factorized form. So we see there is a highest common factor between 2x and 6, and that is 2. So the perimeter is going to be 2 into 2 goes into 2x, x times, 2 goes into 6, 3 times. Therefore, we can be able to say that the perimeter of this figure is 2 into x plus 3 units. Also, this is units because we were not given the measurements. Example 5. The expression for the area of a rectangle is 4x squared plus 8x square units. Find the expression for its width if the length is x plus 2. Now in this question we have been given the expression for the area of a rectangle. We have been told that the width of this particular rectangle is x plus 2. We don't know what the length is, but you are told that the area is 4x squared plus 8x. Now we understand that for us to be able to get the area of a rectangle, it's normally given by length times width. But our length we are not aware, but to know that the area is 4x squared plus 8x is equals to length times the width, which is x plus 2. Let us consider the left hand side, where area is equals to 4x squared plus 8x, and try to factorize this particular expression. When we factorize it, you'll discover that the highest common factor is going to be a number and a value or a pronumeral, and that is 4x. So that will be 4x into x plus 4x goes into 8x twice. What can you say about x plus 2? Our x plus 2 was the width. So this will tell us that automatically the length is going to be 4x. So we can now comfortably say that length times x plus 2 is equals to 4x into x plus 2, because this and this will be eliminated, so that will leave us with length being equal to 4x. So we can now comfortably confirm that the length is 4x units. So the trick is first write that expression in a much simplified form, then try to see how it correlates with the original value or area that was given. Let us consider another example. Example 6, where we are told evaluate the following. Using factorization techniques. 1, we have 9 times 2. We add it to 9 times 5. Part B, negative 5 times 8 added or subtract 5 times 6. Let us try to apply the knowledge in factorization to be able to solve these two questions. Part A, we have 9 times 2 plus 9 times 5. So you can be able to regroup this one into 2, and you'll be able to see that there is a common factor, which is 9, which we can be able to factorize it out, and this will give us 9 into 2 plus 5. 2 plus 5 is 7, and therefore this will be 9 times 7, which the calculator will give us 63. So you can easily be able to break down sums in that nature. Number B, we have negative 5 times 8 subtract negative 5 times 6. Again, you can be able to see that negative 5 is common, hence we can be able to factor it out. That will give us 8 subtract 6, because the sign there is negative. So this will be negative 5 multiplied by 8 minus 6, which is 2, and this will give us negative 10 as the answer. So that is it about how we can be able to factorize algebraic expressions. I now welcome you to the second part of this lesson, where we shall be looking at the fourth subtopic of this topic, and that is factorizing the difference of two squares. Now we can be able to recall something about the difference of two squares. Is that whenever you have a plus b into a minus b, which was forming our third identity, we say that when you expand and then simplify, this will give us a squared minus ab plus ab subtract b squared. You will discover that minus ab plus ab will cancel out, leaving you with a squared subtract b squared. So this is a difference of two squares. Now, if you are at this stage, how do you retrace your way back home? It is much easier. See what you did. You squared. The most important thing is for you to identify the factors that gave you those particular a squareds and b squareds. Then you simply break them and separate or distinguish the two brackets using either positive or negative. So in this case, if you are given a squared subtract b squared and you need to factorize them, then the work is very easy. You simply need the square root of this and the square root of this. The square root of this is a, the square root of this is b. So that will be a plus b in the first bracket, a minus b in the other bracket. So we majorly do it by way of inspection. So let's appreciate some of a few things concerning this. One is that factorizing a difference of two squares uses the rule a squared minus b squared is equals to, we had done it, that will be a plus b, a minus b, where you inspect for the square root of the two numbers. And this, we had said that you can always interchange, there's no problem. You can start with minus followed by positive. Another point or example given is if you have x squared subtract 16, how do we end up with factorization of such? So you only need to know what is the square root of this first part and what is the square root of that. The square root of x squared is x. The square root of 16 is 4. So that means this will be 4x, that will be 4 minus x, 4 plus x. So the only thing that differentiates them is the sign there. That's 1. 2, we can have 9x squared subtract 100. So in this case again you consider and check what is the square root of the first term. It's going to be 3x. What about 100? The square root of 100 is 10. Therefore we use the rule. So this is our A, this is our B. So we're going to have 3x plus 10, 3x subtract 10 interchangeably. This can come first followed by that. We can also have another when we have 25 minus 4y squared. So we simply need to know what is the square root of 25. We know it's 5. Square root of 4y squared is going to be 2y. So when we rewrite them in brackets, this is going to be 5 plus 2y, 5 minus 2y. Only the concept of the sign is going to be different. Now there is an important aspect whenever you want to factorize difference of two squares. That is, if there is a common factor, take it out first. So first, take out a common factors, a common factor or factors where possible. We are saying where possible because, like the 4 cases we have seen, there was no case where we are first taking out the common factor. For example, given, if you have 2x squared subtract 18, knowledge tells you that if you keep struggling to keep looking for the factors of this, then you are not going to get it. But if you are keen enough, you'll be able to discover that there is a highest common factor between these two terms, 2x squared and 18, and that common factor is 2. So when you take it out, we are going to have 2 into x squared minus 9, and therefore what remains inside the bracket is a difference of 2 squares. Now look for the square root of x, which is x. Look for the square root of 9, which is 3. So this means we're going to have 2 into x plus 3, x minus 3. So we should be able to factorize it out first whenever we have a common factor. Let's look at a number of examples on how we can be able to factorize difference of 2 squares. Example 1, factorize each of the following. Number 1, we have x minus 4, x squared minus 4. Number B, 9a squared subtract 25. Number C, 81 x squared minus y squared. D, 2b squared subtract or less 32. Then E, x plus 1 squared, we subtract 4. Now solution, part 1, we have got x squared subtract 4. We said that for us to be able to factorize, we need to get the factors. So you get the square root of x, it is x. The square root of x squared, it is x. The square root of 4 is 2. Then we put them in brackets, differentiated by the sign. So the first bracket, you can have x plus 2 into, you open another bracket, x minus 2. So simply the sign changes. Number B, we have 9a squared subtract 25. Now in this particular case, as you can be able to see, on the first case, the square root of 9a squared is going to be 9, is going to be 3a. The square root of 25 is 5. Therefore, you put these factors in brackets. That will be 3a plus 5 multiplied by 3a subtract 5, and you are done. Number C, we have 81x squared minus y squared. Now there is the square root of 81x squared is 9x, the square root of y squared is y. So we put them in brackets. This will be 9x plus y multiplied by 9x subtract y. So you find it's much easier, especially when you can be able to detect and give out those particular square root of those given numbers. Number D, we have 2b squared minus 32. You can scratch your head and scratch it and scratch it, and you'll never get the factors. So you can be able to see that there's 2b, there's 32. That means, or tells you that there's a common factor that must be singled out. So when we single that 2 out, it's going to leave us with 2 into b squared subtract 32 divided by 2 is 16. And whatever we now have inside the bracket is a perfect, or is a difference of 2 squares, which have the factors of a and 4. So this will be 2 into b plus 4, b subtract 4. So you first pull out or take out the common or the highest common factor. Now lastly, number E. E first requires us, we have x plus 1, the whole of it is squared, then subtract 4. So good knowledge tells you that if the whole of this has been squared, then the square root will be x plus 1. And then the square root of 4 is going to be 2. So we simply put them into bracket. The first one, we're going to have x plus 1 plus 2, the whole of it multiplied by x plus 1 subtract 2. So when we simplify, 1 plus 2 will be 3. So this will be x plus 3. We multiply it to x subtract 1 minus 2 is minus 1. And therefore in expanded form, we are going to have x plus 3 multiplied by x subtract 1. Example 2, we are told the height above the ground of an object thrown thrown off the top of the building is given by 36 less square of 4 square of t where t is in seconds. The first question is A. Factorize the expression for the height factorize the expression for the height of the object. So let us first solve this part where we are told to factorize the expression for the height of the object. So we are told that this object is falling from a height of 36 minus 40 squared, where t is time in seconds. So that means that our height is equals to 36 subtract 40 squared. So they want us to factorize this particular part, and the first thing that we're going to do is that we're going to eliminate or factorize the or take out the common factor. You can be able to see that 36 and 4, we have 4 as a highest common factor, so that will be 4 into 4 goes into 36 9 times, we subtract 4 goes into 4t squared t squared times. So this leaves us with a difference of 2 squares, which you can now easily be able to factorize. So when you factorize, the square root of 9 is 3, the square root of t squared is t. So that will be 3 plus t multiplied by 3 less t. So we have been able to factorize. Number B, find the height of the object find the height of the object 1 initially. So when you talk about the initial height, that means immediately before you threw it down. That means time t was equal to 0. Then 2 at 2 seconds. So at 2 seconds, t will be equal to 2. Now for us to be able to solve the first part, we were able to say that the height will be equal to 2 into 3 plus t, 3 minus t. Our t, we have said, is 0. So when you make the replacement, this will give you 3, this will give you 3. So 3 multiplied by 3, that will give you 9, and therefore our height is going to be 2 multiplied by 9, which is going to be 18 meters. So that means initially that object was 18 meters above the ground. When the time is equals to 2 seconds, we make the replacement in the formula or the expression for the height, that is 2 into 3 plus t into 3 minus t. And when you make that replacement, where there is t, you put 2, this will be 5, and this will be 3 minus 2, which is 1. So 5 times 1 is 5, 5 multiplied by 2, you are going to get that h is going to be 10 meters. So that means after 2 seconds, the object will be 10 meters above the ground. That means it will have come down. Part C of the question, how long does it take for the object to hit the ground? How long does it take for the object to hit the ground? So we are told that the height was given by 2 into 3 plus t, 3 minus t. We have been told to calculate the time at which the object is going to fall on the ground. We had said that the object is 18 meters above the ground. So when this body falls, that means that the final height is going to be 0, that is at the ground. And that means we are going to make our substitution here with 0. So that means that 2 into 3 plus t into 3 minus t is equals to 0. We divide through by 2, and this will leave us with 3 plus t, 3 minus t is equals to 0. That means there are two answers for the values of t. The first one, 3 plus t is equals to 0, and this will give us t to be equal to negative 3 seconds. The second one, we have 3 Example 3, we are told we have a multi-size square picture frame has side length has a side length 30 centimeters and hold a square picture with any side lengths less than 26 centimeters. First question is, if the side length of the picture is x centimeters, write an expression for the area of one picture to frame, and it should be in factorized form. So let us first begin by solving these two. We are told that there is a multi-size picture frame that can be able to hold a picture of side x centimeters, but the square is measuring 30 by 30. So we want to express the area of the picture. Now this picture will be a square picture measuring x by x. We now want to get its area, and area will be given by length times length, which is x times x, which is going to be the square of x. Part B, we want to get the area of the frame. The area of the frame alone will be 30 multiplied by 30. We subtract the area of the picture. That will be 30 squared. We subtract x squared. So when you do this, you'll get 900 subtract x squared. But we want to write this expression in a simplified and in a factorized form. So we look for the square root of 900, which is 30, and the square root of x squared, which is x. So this means we are going to have 30 plus x multiplied by 30 minus x, and it is centimeters squared, which means it's a difference of 2 squares. Part B of the question says that use your result in part 1 Roman 2, that is our result, to find the area of the frame. Find the area of the frame if 1 x is equals to 20 units, and 2 area of picture is equals to 225 square centimeters. So the solution to this question is much easy. We had said that the area of the frame is equals to 30 plus x, 30 subtract x. But now our x is 20, so we substitute x is equals to 20 in the simplified expression. This will be 30 plus 20 multiplied by 30 minus 20. And this will give us 50 multiplied by 10, which will be equal to 500 square centimeters. Now part B requires us to find the area of the frame if the area of the picture is 225. You can be able to recall we said that the frame or area of frame will be given by 30 squared subtract x squared, where x squared is area of the frame. So this means that the area of the frame, where x squared is the area of the picture, so that means the area of the frame is going to be 900 subtract the area of the picture, which is 225 square centimeters, and that will give us 675 square centimeters. So this brings us to the end of our lesson today on how we can be able to factorize the difference of two squares. Always remember that before you proceed, you must ensure that you eliminate or you remove the most common term or factor first. Next time when we meet, we are going to look at how we can be able to group by pairing. Thank you.